Hello everyone, and welcome to the video where we actually start making our game in SDL. So we'll be using the framework that we created in the last series, and I will show you how to actually use that framework to create a game that you want to make. So I call the framework Quick SDL, and I have it right here. So if I open it up, as you can see, it's just the bare framework that we had from last time. And to make a game using it, you just need to copy and paste the whole project folder. So copy and paste it, and we'll call this one Galaga SDL. And now that we have it here, we can open up the solution for that. And in our solution, we'll change this to Galaga SDL. Or maybe we can just, well, Galaga SDL is fine. And for this one, will be Galaga SDL. And this should be it for setting up our framework. Next up, we will go to our graphics.h. And in here, we can choose what we want our screen width and height and title of the game will be. So we'll call this one Galaga. Our width will be 1024. And our height will be 896. So if we try to run it now, there we go. So we have Galaga here, and our width and height is that much. So we are going, in this video, we're going to be making the start screen for Galaga. And this is the first screen that we're going to create. So for that, we are going to go into our header files, and we'll create a new filter. We'll call this one Galaga. And in our source file, we'll make a new filter, call this one Galaga as well. And then in here, we'll create a new item. This will be a .h, and this will be our start screen. So in here, we'll do the usual. So if not defined, underscore start screen, underscore h, define underscore start screen, underscore h, and then end f, class start screen. And then we will do a few things that we need, we will include. So include animated texture.h, and we'll also include input.h, so input manager.h. And since everything in the framework is now wrapped in the namespace Quick SDL, we'll say that we're using namespace Quick SDL. And now for our start screen, this start screen will be inheriting from game object, and this way we can, so this needs to be a public inheritance, and this way we can attach objects directly to our start screen, and they will have a position, so this way we can translate the whole start screen and all its children at the same time. And this will come in pretty handy when we're trying to slide the screen from the bottom to the top to the middle of the screen. So the first thing that we're going to create is our private entity and our public. So our private and public sections. In private, we will create our top bar, and what we're trying to create here is the NES version of Galaga. So let's say Galaga NES. And for this one, we are going to try creating the start screen for this. So it's something like this. Or this one, to be more specific, I guess. Something around that. So what we'll do first is to have our so we want 1 UP, high score, and 2 UP. And we'll call this section our top bar, so that if we're trying to slide anything down or up, we can move all these at the same time. So we'll create first the game entity, pointer called mTopBar, and then a texture pointer called mPlayer1, and a texture pointer called mHighScore, HiScore, and then a texture pointer called mPlayer2, or 2. There we go. So these are the three variables that we'll need for now. For this, we'll section it off, calling it top bar entities. And then we'll create our constructor and destructor. So start screen, and then start screen. And finally, we'll do a void update as well as a void render. So now that we have these set up, we can go ahead into our CPP. So add new CPP, and we'll call this one start screen, and we'll include our start screen.h. Now let's create our constructor. So start screen, and then start screen. Did I not put? No, I did not. There we go. So that's the destructor. So start screen destructor, and then void update and void render. So this one, of course, is start screen update and start screen render. And this will be it for that part. So now we can go ahead in our game manager. So we can open up game manager, and over here we will do include start screen.h. Since start screen.h includes texture and the input manager, we don't need to include him here, so we can take him out. And then all the way down here we'll say start screen pointer mstart screen. So we're creating a new instance of that in the game manager.cpp. Down here we'll say mstart screen, so that's in the constructor, equals the new start screen. And then in the destructor we can destroy it, so delete mstart screen equals null. And then in the update we'll do a start screen update. And then in the render we'll do a start screen render. And this will be it for our game manager. So now we can go back to our start screen and start creating our textures that we need. So the first thing that we're going to need is the font that we're going to be using. So if we go open folder, and as you know, in our debug we need an assets folder, and we have that already in our framework. We're not going to be needing any of this, so we'll delete all that. And I already found a font that is for Galaga, so I have it here called emulogic.ttf. You can just Google that and find it. And now that we have it here, we can get started on creating the textures that we need. So the first thing that we'll do is say top bar entities. We'll say that mTopBar is going to be equal to a new game entity, and the position of that is going to be in the center of the screen, so vector2. And to get the center of the screen we just need to get the graphics instance. So graphics, not initialized but instance, screen width multiplied by 0.5f. And it's a little low on the screen, so as you can see here there's an empty space at the top, so we'll move it down a little bit. So we'll say it's something like 80.0f, and this will be it for our top bar. Next up we need to do the 1up, so we'll say that mplayer1 is going to be equal to a new texture, and this will be a font texture, so we just need to give it a string, so 1up. And the font that we're going to be using is emulogic.ttf. The size of this font, let's say 16. And then finally the color, and for that color we'll give it a struct, so it will be it's a little red, so we'll say it's something like 200, 0, and 0, because it's not very bright red, but it's a little dark-ish red, so we'll say that is something like 200, 0, and 0. We'll do the same thing for the high score, so m high score, but instead of this it will say hi-score, and we'll keep it just like that, and then player 2, so M player 2, and this one will say 2UP. 2UP. Okay. So next up, we'll attach these three as children of the top bar. So we'll say M player 1, parent is the M top bar, M high score, parent is the top bar, M player 2, parent is the top bar. And then since we created 4 things with new, we should probably delete them. So top freeing top bar entities. So delete M top bar equals null. Delete M player 1 equals null. Delete M high score equals null. Delete M player 2 equals null. And now we're clearing everything. The last thing we need to do for these 3 is to render them. So M player 1 render, M player 2 or M high score render, and M player 2 render. So every texture starts off being at 0 and 0 in world space. So even after we attach them as a parent for top bar, they should stay at 0 and 0 in the world space. For example, if I try to run this, you'll notice that all of them are here at the top left corner. So we need now to zero them onto our top bar position. So we'll say that our M player 1 position is vec2 underscore 0. And we'll do the same thing for the high score and player 2. And now if we try to run it, as you can see, they're all in the middle here. And this size seems a bit too small for the font. So we'll increase it to 32. So we'll say our font is 32 instead for all of them, and try to run it. And there we go. So the reason why the background is white is because we probably need to edit our graphics.cpp. So if we go down to the managers and graphics.cpp, in the init function, we are setting our render draw color to white. So we want the draw color to be black instead. This way we don't need to draw a black texture every time because our renderer will be cleared to being black. So there we go. And now we have our black screen with high score UP and 1 UP and 2 UP right here. So now we just need to separate them. And you'll remember that once we parent an object to another object, the children's position is relative to the parent. So now when we're trying to move the position of this object, we can just, as long as we don't edit the Y value, it's going to be on the same Y as the parent, and we can just shift the X value. So we'll say that this one is going to be equal to a vector 2, so this is 1 UP, so it needs to go to the left. And since the 0 of the parent is right in the middle of the screen, it needs to go to the negative side of things. So we'll say that its position is going to be equal to negative of graphics instance screen width multiplied by 0.35 f. And on the Y, it's going to be 0.0. So this is it for 1 UP. So we want it to be 30% of the screen to the left, or 35% of the screen, that is. So there we go. So now we have it over here. High score is in the middle, and then 2 UP we wanted on this side. So that's positive. So we'll take what we did here in player 1 and paste it here. But now instead of negative 35%, we'll say it's positive. So we'll remove the negative value, but we'll say that it's positive. Let's see where 35 on positive takes us. So, and it's all the way over here. From what I see here, 2 UP is not that far off to the right, so we need to move it to the left a little bit. So instead of 35%, we'll do something like 20%. And let's see where we end up from here. So this seems about right, but we probably need to move high score a little bit to the left. So for high score, we'll say vector 2. And in here, we'll say it's, let's say, negative 30.0f and 0.0f on the y. And then if we run it, and this seems about right compared to this. So this seems pretty good. And the nice thing about doing it this way is that if we translate the top bar at all of these translate with it. For example, if I say m top bar position is, let's say, vector 2 of, we still want to stay in the middle. So this, graphics with that. There we go. So still in the middle, but let's say it's at 500.0f. So if I do that and run it, so I translated just the top bar and the entire thing translated down. And that's the really nice thing about this hierarchy system. So now we can take this out. And we have all this. The final thing we need to do is assign top bar to be child of the start screen. So down here we'll say m top bar. Parent is this. And this is just a pointer to our start screen. Okay, so this is the first part of all of this. So next up we need to do the 1-player and the 2-player part. We'll get to the Galaga logo later. So for this, we will do the exact same thing. It will be a repeat of what we did here. So we'll say play mode entities. And this will take a game entity pointer m play mode or m play modes. And then a texture pointer m 1-player mode. And a texture pointer m 2-player mode. And with that, we can go ahead and go back to our CPP and do the stuff. So play mode entities. And our play mode is going to be the same idea as our top bar. So our m play modes is going to be equal to a new game entity of vector 2 centered on the screen. So graphics instance screen width times 0.5f. So that's our x. Our y, you'll notice that this is somewhere like at 55% down on the y. So we'll use our height, the screen height multiplied by 55%. So this will be graphics instance screen height multiplied by 0.55f. And this will be it for our play modes. Next up is our 1-player mode. So m 1-player mode is going to be equal to a new texture. It's the same font as these ones. So we'll say 1-player. The font will be emu logic.ttf. And the size will be 32, just like the other ones. But the color is sort of a faded out white. So we'll say it's somewhere, it's something like 230, 230, and 230. And then we'll do the same thing for the 2-player mode. So this is 2-player mode. This one, 2-player. 2 players. There we go. And all we need to do here is to just say that our 1-player mode and 2-player mode are children of m play modes. So m 1-player mode. Parent is m play modes. m 2-player mode. Parent is m play modes. And then m play modes parent is this. And then we just need to set the position for 1-player mode and 2-player mode. So m 1-player mode position is vec2 underscore 0 for now. And the same thing for 2-player mode. So 1-player mode, position 0, and 2-player mode, position 0. Now we need to clear all this, so freeing play mode entities. So delete m play modes equals null. Delete m1 player mode, m1 player mode is equal to null. And delete m2 player mode, m2 player mode is equal to null. And then down here we will render these things. So m1 player mode render, m2 player mode render. So let's go ahead and run this and see how it goes. And there we go. So now both of these are here. So we need to move one player up a bit and 2 players down a bit. So we'll go here, and in the position, instead of vector2 0, we'll say that it's a vector2. We don't want to move it on the x for now, but on the y, we'll set this to negative 35.0f. And this one will be the same, but it's going to be 35.0f. And then let's run it again and see where they end up. So this seems pretty good, but one player is too far to the right. We can move it a little bit to the left. For that, over here on the X for 1-player mode, let's move it by negative 35, let's say. And this seems to be a bit too far on the to the left. So let's say something like negative 20. And this seems pretty good. It might be like 1 pixel to the right, so let's say negative 19. Or 1 pixel to the left too far. So yeah, so this seems pretty good. It might still be a little bit off, so let's say 18. And there we go. So this seems pretty good. So now we have our play modes set up. So 1 player and 2 players is set up. So the last thing we need to do is set up the dates and the rights and all that stuff at the bottom. And for that, we will create another set of entities. So we'll call this one bottom bar entities, game entity pointer, mbot bar, texture pointer. This will be Namco, which will be the thing that will say Namco in red. Texture pointer, dates. So this will be the release date and all that stuff. And a texture pointer, rights, which would be the one that says rights reserved. So we'll go back here again and say bottom bar entities. And these bottom bar entities will be the same setup as this one. So mbot bar is going to be equal to new game entity. So we're setting the game modes at somewhere around 55%. We'll set this one at like 70% down instead because it's further down. So vector2, it's still centered on the X, so graphics instance screen width multiplied by 0.5f, and then for the height will be graphics instance screen height multiplied by 0.7f. So this is now centered on, oh, we need one more bracket here. So this is now centered or 70% down and centered on X. So for Namco, the Namco logo, it uses a different font. And for that, I found another font for it. And this one is called Namco__.ttf. So for that, I will say that mNamco is equal to a new texture. And this texture will take a string Namco. I think it said Namcot in the NES version. Not sure why, but there we go. And the font will be namco__.ttf. The size will be 36, and the color will be, it was a red color. So we'll say it's something like 200, 0, and 0, just like the UP, the 1 UP and the 2 UP. So we have that. Next up are the dates. So we'll say mdates equals a new texture. But this one, the font is the EMU logic. So I think, so this one said, let's see, 1981, 1985, Namco Ltd. Namco Ltd. Dot. Now the font was EMU logic.ttf. The size, we'll keep it the same at 32. And the color was the same as the 1-player mode and 2-player mode. So 230, 230, and 230. The mWrites is going to be equal to a new texture of, and all this will say is all rights reserved. All rights reserved. And this will be the same font, so EMU logic.ttf, 32 and 230, 230, and 230. And there we go. Now we need to do the same thing, attach them as children to the bottom bar. M bottom bar, or M Namco. Parent is M bottom bar. M dates. Parent M bottom bar. M writes. Parent is M bottom bar. And there we go. Now M bottom bar. Parent is going to be equal to this, just as usual. So this is it for that. We need to just center these now, so set their positions. So M Namco position back to 0. And we'll do the same thing for the other two. So dates and writes. Then we'll go down here and clear this. So we'll say M bottom bar. So freeing bottom bar entities. Delete M bottom bar. And M bottom bar is going to be equal to null. M Namco, or delete M Namco. And M Namco equals null. Delete M dates. M dates is equal to null. And then delete M writes. And M writes is equal to null. Finally, we just need to render them. So M Namco render M dates render and M writes render. So let's run it and see what we get. There we go. So now we have it. We have them right here. Namco seems to be in the right spot, so we just need to shift the other two downwards. So for that, so we'll keep Namco at 0. For dates, we'll say it's a vector 2. We don't want to move it on the x, so 0.0f on the x. But on the y, we'll move it down to like 90.0f. And let's see where this ends up. So this is here. This looks pretty good. Now to move on to the other one. So we'll take the same thing. So 0 on the x, but on the y, well, let's say it's something like 170.0f. So for the rights, And yeah, this looks pretty good. We can keep it here. And this will be it for the bottom bar. So the only thing left is our logo. So the logo, I already made a logo over here, and this is what it looks like. So I have this thing here. I have a Galaga logo that's dark green, and then lighter green, and then very light green. And I have it set up so that it's just a sprite sheet pretty much. So for our static logo, we only want this one. And you'll remember that our texture class can handle clip textures. So that's what we're going to use for the static logo. So what I will do is take this logo and paste it in where I have my assets. So I'll take this one and paste it here. And this is what it looks like again. So I will go over here, and the logo is in between the top bar and the play mode, so I'll keep it here and say logo entities. First, I'll create a texture pointer called mlogo, and mlogo I will load it up using the logo that I just added. So I'll put that right here just to keep everything organized. So logo entities. And I can just attach the logo directly onto the screen. So I'll set the parent of the logo as this. So mlogo equals a new texture, and this texture is called Galaga logo.png. So Galaga logo.png. But I only want the first texture, so I'm starting from 0 and 0, so the top left corner of the image, and I know that the width and height of each one of these cells is 360 by 180. So that's what I'm going to use. I will say that it's 0 and 0. The width is 360 and the height is 180. Now I'll say that the logo's parent is this, and mlogo position is going to be centered on the X, so vector 2. So graphics, where do I have it? So graphics instance screen width times 0.5f, and on the Y I want it somewhere between this and that. So this is 0.55, so let's say 0.4 for example. So graphics instance screen height multiplied by 0.4f. And we'll see what ends up happening once we do this. So we have it set as the child of the screen. So we can go down here and free it. So freeing logo entities, mlogo. So delete mlogo. Mlogo is equal to null. And then we'll go down here and mlogo render. So let's see what it looks like now. Okay, so it seems a bit too low. So let's raise it up a bit. So we have our logo right here. So instead of 0.4, let's say 0.3. There we go. It seems a bit too close to this, so we'll move it down just a little bit. So let's say 0.32f. And there we go. So this looks centered now. And now we can go ahead and make the screen slide up from the bottom. And all we need to do this is to just scroll the entire start screen, because it is a game entity and all of these are attached as children to it. So all we need to do is change its position, and the position of all these entities will change at the same time. So to do this, we will need a few new variables. we will go all the way down here and say that these are variables. So screen animation variables. We'll create a vector2 and we'll call this one M animation start position, and another vector2 with M animation end position. Then we'll create a float with the M animation total time, a float with M animation timer, and finally a boolean M animation done. So the total time is how long it'll take to do the animation. The timer, we're going to use this to go through the animation, and then animation done will be true when the animation is done. So over here, all the way at the bottom, we'll say animation, or what did we call this one? Screen animation variables. Screen animation variables. So let's see here. We want the screen to start off screen. And right now the start screen is starting at 0. So for all of these to go underneath the screen, we need to set the Y to be the entire screen's height. So M animation start position. So the starting position is going to be equal to vector2 of the middle of the screen. So graphics instance screen width multiplied 0.5f, and then all the way down. So graphics instance screen height, and this will be our starting position. Our end position will be at 0 and 0. So our M animation end position is going to be equal to vec2 underscore 0. And then M animation timer total time is going to be equal to 5.0f. So we want the animation to be 5 seconds long. M animation timer is going to start off being 0.0f. M animation done, of course, is going to be false to begin with. And this will be it for this part. Now we can go to our update and see what we can do with that. So we'll say that if the animation is not done yet, so if not animation done. So now to increment M timer, we need the timer, or the delta time. And to get that, we will need to get our time. So if we go to back to screen, start screen.h, all the way at the top, we'll say timer pointer, M timer. And timer is included in animated texture, that's why we have access to it. So we'll go into start screen, and all the way at the top, we'll say that our M timer is going to be equal to timer instance. And that's what we need. So down here now in update, we'll say that our M animation timer is going to plus equal M timer delta time. So now that we have this, we need a way to interpolate between two vectors, because we have our start position vector, our end position vector. So to interpolate between these two, we need to edit our math helper. So we'll be doing this throughout the series. We're going to be editing the framework only in the places where we need to edit it, and then we'll update the framework once the project is done. So inline vector2 lerp, and we want, so lerp, and we want to interpolate between two vectors. So we'll say vector2 reference of start, vector2 reference of end, and a float for the time. So the first thing we need to check is our time is going to be between 0 and 1, and if the time is less than 0, we'll just return start. If the time is more than 1, we'll just return the end. And then if it's in between, we'll linearly interpolate between the two. So if time is less than or equal to 0.0f, return start. If time is more than or equal to 0.0f, or 1.0f, So if time is more than 1.0f, return end. Otherwise, we need to interpolate between the two. And to do that, we need the direction of the vector between these two. So we'll say vector2 direction dir is going to be equal to end minus start dot normalized, and this will give us the directional vector from start to end. And then float mag is going to be equal to end minus start dot magnitude. So this is the magnitude of our vector, and then we'll just return start plus the directional vector multiplied by the magnitude multiplied by the time. And this will be our linear interpolation between two vectors function. Now we can go ahead and use that in our start screen. So here in update, we'll say our screen's position, so the position, is going to be equal to a lerp. So as long as we're animating, it's a lerp between m animation start position and animation end position. The time is going to be our m timer divided by our total time, so animation total time. And this will be it for the lerping. Now, once the lerping is complete, it's going to complete if the animation timer is equal to the total time. So if m animation timer is more than or equal to m animation total time, then m animation done is equal to true. And this will be it for this part. So over here, now we need to set the position of our screen. So we'll do it all the way at the end here. We'll say our position is going to start off being our animation start position. And that will be it for this part. So we can go ahead and try it out and see what happens. Oh, so something is off here. And that's because our end position is wrong. So our end position should be the middle of the screen and 0, not vector2.0. So vector2 graphics instance screen width multiplied by 0.5f and 0.0f. So this is what our animation end position should be. So let's try that again. Okay. Oh, right. Our start screen needs to start at 0 and 0. Right. So it's going to be our x is what's messing it up. So 0.0f on the x and 0.0f on the y, because everything is set up relative to the 0 and 0 position in the world. So 0.0f and max height, and then 0.0 and 0.0. So we can return this back to vec2 underscore 0. There we go. So this should work now. I hope. There we go. All right. So this is now animating up, and then it's going to stop right here and end our animation. So this seems to work pretty well. Now, what we need to do is to do the animated texture to make the Galaga logo flicker once the animation is done. For that, we will go to our logo entities and create an animated texture pointer, and we'll call this one animated logo. And then in start screen, underneath logo here, we'll say animated logo is equal to a new animated logo, animated texture. The name is going to be Galaga logo.png. Now our X is going to start off at 0, Y is 0, width is going to be 360 because each frame is 360 wide and each frame is 180 high. Now the animation speed, let's say it runs through the animation in 1 second, and the animation or the frame count is 3 frames, because if I open up this, we have 1, 2, 3 frames, and they're arranged vertically. So we have 3 frames. It runs through in 1 second, and animated texture vertical. So this should be our animated logo. Now we can set it as a child to this. So animated logo parent is this. And the animated logo's position should be the same as the logo's position. So we'll just copy this and paste it and change the logo to animated logo. Now we go down to our destructor and delete it. So delete animated logo, and animated logo is equal to null. So now that's done. We can go down and say that as long as the animation is running, render the logo. So if not animation done, render the logo, else animated logo render. And we need to update the animated logo to run the animation. So as long as the animation is running, we don't want to update it. And then else animated logo update. And there we go. So let's run it and see how it goes. So the static logo is there. And then once it hits here, as you can see, the animated logo is animating. But it seems to be animating a bit too slow. So we'll go to where we're creating our animated logo and change our time from 0.1 to, let's say, 1.0 to 0.2. So we want the whole animation to run in 0.2 seconds. And let's now see what happens. And there we go. Now we have the logo running. Okay, so finally, the last thing we need to do now is to do the selection of the game modes between 1 player and 2 players. And for that, we will need a cursor. So I had a cursor, I made a cursor earlier in our assets. So this thing right here, I have a cursor.png, and this is what it looks like. It's just a small texture with the cursor on it. So I will go back to startScreen.h, and in play modes, I will add my cursor. So texture, pointer, cursor. And down in the play modes area, I will create my cursor. So cursor is equal to a new texture. And this new texture, I think it's called cursor.png. So, and since it's not a sprite sheet, we can just leave it at that. We need to assign this as a child. So cursor, parent is our play modes. And then the position of the cursor, let's start off being at 1, and then we'll move it to the left. So cursor, position is going to be a vector 2 of, let's say, negative 18.0f and negative 35.0f, negative 35.0f. That's where our player 1 is, or 1 player is. And then let's move it to the right. So let's say it's something like 150 instead on the X. So now we are adding it and then doing this. We need to go down to our play modes and delete it. So cursor, or delete cursor, and then cursor equals null. Then down here we will render cursor. So cursor render, and then let's see what it looks like now. So there's our cursor. It's a bit too close to 1 player, so we'll move it back a bit. So our cursor's position, let's say 170, negative 170. There we go. I still feel that it's a bit too close, so I'll move it back like 5 more pixels. So let's say negative 175. Okay, so I'm pretty happy with that. The final thing that we need to do is to make the cursor move up and down using the arrow keys. So for that, what we will do is to create a starting position for the cursor and an offset for the cursor, how far we want it to go up and down. So we'll create a vector 2, m cursor start position, and a vector 2, m cursor offset. And then int m selected mode. And this will be either 1-player mode or 2-player mode. So over here in our play modes, we'll say that maybe we'll do it down here. Our m cursor start position is going to be equal to this vector 2 right here. So what we can do is say that it's going to be equal to our cursor's local position. So the cursor start position is our cursor's local position right now because it's on the right, at the right position. The offset is the difference between these two, which is 70. So m cursor offset is going to be equal to a vector 2 of, we don't want it moving on the x, so 0.0f, and on the y it needs to go down by 70, so 70.0f. And then m selected mode is going to start off being 0. So this should be fine. Next up, we need a function to switch between the play modes. So we'll create a void down here, void change selected, I think selected mode, and this int change, and let's implement this function. So for this function, we will go back to start right above update. We'll say void change selected or start screen, change selected play mode, and change. We will increment the m select play mode, so m select by change, so plus equals change, and then wrap it around. So if m select play mode is less than 0, we want it to be equal to 1, so m selected play mode is equal to 1. And if m selected play mode, or maybe an else if in that case, so else if selected play mode is more than 1, we wanted m selected play mode is equal to 0. So now that we're switching between the two, we want to also change the cursor's position depending on the change. So m cursor position is going to be equal to our m cursor's start position plus our cursor's offset multiplied by the m selected mode, because our m selected mode is between 0 and 1. And this will change between the two for us. So the final thing to do is to just catch the key presses for up and down keys and change the play mode accordingly. To do that, we will need to create an input manager instance. So input manager pointer m input. So we'll create it here, and in the CPP we'll go all the way up and say m input is going to be equal to input manager instance. And then we only want to do the change if the animation is done. So we'll say that if m input key pressed SDL underscore scan code underscore down, we want to do a change selected mode increase by 1, else if m input key pressed SDL underscore scan code underscore up, we want to change selected mode by -1. And this should be it for that. So let's go ahead and run it and see how it goes. So we can only change after the animation is done, and once it's done, we can press up to switch between the two or press down to switch between the two. And since we have our m selected game mode, we're keeping track of which mode we're selecting. So if it's 0, it's 1-player mode. If it's 1, it's 2-player mode. So maybe we want it now to finish the animation if we press up or down while the animation is running. So if input key press down, or input key press, so we pressed up or down, we want to say that our M animation timer is going to be equal to our M animation total time. That will make it so that when the next frame comes, it just ends the animation instantly. So let's see how it goes if we do that. So the animation is running, I press up, and the animation is done, and I can start picking what I want to pick. So for the background and the stars, we'll do that in a separate video. It's already getting close to an hour for this video. But now we have our start screen. We still haven't put in the scores. We'll put that later on. But we have our start screen. We have our animated Galaga logo. We have our selection between the game modes and everything here. And we have the animation for the start screen to come up from the bottom. So this will be it for this video. If this video helped, if you have any, I really hope that it helped. If you have any suggestions, questions, or feedback, please leave them below in the comment section. Otherwise, thank you very much for watching, and I will see you in the next video.